Hey guys, in this video we'll be going over the Physics 103 Discussion 2B Useful Expressions. Starting in the far left we have our velocity expression at a constant acceleration. What this means is that if you have an initial velocity and you are traveling at a constant acceleration, which I'll abbreviate like this, and you're moving at this constant acceleration for a certain amount of time, your velocity will change and you'll end with a new velocity. Let's see this put to use in a drawing. So let me rewrite the equation really quick. Now let's say there is a cliff, and at the bottom of the cliff leads to a beautiful ocean. Now I'm at the top of this cliff and I decide to drop a pebble straight down into the water. And I watch it and it seems to speed up faster and faster and faster, and then it hits the water. Let's map these variables in the equation to the actual situation drawn underneath that equation. So our initial velocity in this case is 0 meters per second. So the pebble starts, technically, this is my outstretched hand, it starts in my hand, and when I let go it begins to move. Now the acceleration, that is gravity. And gravity is an acceleration of 9.8 meters per second squared. So what does that mean? That means after 1 second of traveling, specifically the first second of traveling, the pebble will have dropped 9.8 meters. Now the corresponding velocity, therefore, is 9.8 meters per second. Now the second 1 second interval, bracketed there, the pebble will have dropped 9.8 meters plus another 9.8 meters. That corresponds to a velocity of, hopefully I do my mental math right, 19.6 meters per second. And we could say the same thing for the third second of travel, 9.8 plus 9.8 plus 9.8. And that is a 1 second period of travel with a corresponding velocity of 14, trying to do math on the spot here, 29.4 meters per second. So what's going on? If you have an acceleration after each second of travel, your velocity picks up. Let's move on to the second equation. Let me switch colors. This is more a position equation given the x. So it's saying if you have an initial position, you're going to add the initial velocity multiplied by time plus 1/2 our constant acceleration multiplied by time squared. Okay. This type of equation is really common for parabolic or projectile motion questions. We can draw out a picture. Now, let's imagine that instead of dropping a rock straight down, let's say I throw it kind of like a football, and then it hits the ground a certain distance away from me. I'll clear this up a little bit. We could actually calculate, if this is my initial position, we can calculate what that final position is, or in other words, calculate the distance of how far I threw the pebble, if we know a couple things. One, the initial velocity. So in the case of the pebble drop, the initial velocity was 0. But with my throw, the initial velocity is the speed it travels the moment it leaves my hand. And you guys will see that type of phrasing in your test questions. The moment it leaves your hand, or the initial speed. you would have to take into account, well, how long it's in the air, and that's just our time. And then the acceleration is actually gravity, which is acting on this, and I'm representing gravity as an acceleration force with a down arrow. Gravity is acting on that pebble at every single point during its projectile motion, or its parabolic path, and that is 9.8 meters per second squared. So that takes account for our acceleration, our time, our initial velocity, and our initial position. Therefore, we can calculate our final position using equation 2. All right, last but not least, equation 3. Similar to equation 2, but now we were able to calculate our final velocity, or VF, given an initial velocity plus 2ax minus x naught. Now, remember, we said that the difference between x naught and x is the same thing as distance, and that's how we can think of this term here, where that's delta x, and delta x is the same thing as distance. So sometimes this equation is simplified where final velocity squared equals initial velocity squared plus 2 times the acceleration times the distance. Now we could apply this equation to really any type of problem that has constant acceleration. So that could be throwing the pebble or football in a projectile path or parabolic arc, or it could be in the pebble drop example if we want to calculate the distance of the cliff, aka the drop point to the point that it hits the water, or we could calculate the final velocity where it hits the water. So these equations are going to be super helpful for the rest of this unit and for units to come.